Hello everybody, welcome to your first video lesson of the year because I'm not here. You should be on this page. You should have already submitted your homework into Google Classroom and turn here and get ready to take some notes. So today we are going to be talking about parent functions. And so parent functions are basic functions without any transformations, which we'll get into transformations a little bit later today. But for right now, we just want to talk about these parent functions, all of which you should have learned in Algebra 2. So these shouldn't be new to you. They should be pretty straightforward. So the first one is what we call the constant function. And so that is any just like horizontal line. That looks something like this. And so the domain of a constant function is going to be all real numbers or negative infinity to infinity. This would be considered like the function, we call it equals c. In this specific scenario, this function would be that it equals 3. And so that would be a horizontal line. So where c is just some constant. And the range for this would just be that y value that it passes through, that c. Again, domain is left to right, range is bottom to top. So we just have that one value in the range. Now, the identity function is the function f of x equals x. And so that is a line through the point 0, 0, right? That's the y-intercept. With a slope of 1. So that rise over run is just a positive 1. And so that looks something like this. So this would be that parent function. So because this is a line, again, the domain is going to be all real numbers. And the range will also be all real numbers, right? We're touching all of the x and the y values there. So those are the first two. The next one we have is a quadratic function. And so this has specific parent function points. So one point is going to be 0, 0. Another one is 1, 1. And then the third one is 2, 4. So these are those parent function points, which I'll usually abbreviate as PF points, but we'll write them out, parent function points. And then what we can do is we can actually use symmetry to graph the other side. And so what I mean by that is the parent function is symmetrical about the y-axis. So for 1, 1, that would also give us the point of negative 1, 1. And for 2, 4, that would give us the point of negative 2, 4. There is another point that's not on this specific graph, and that would be 3, 9 or negative 3, 9. But this is that parabolic function. It's kind of shaped like a U. We want to make sure it is not shaped like a V. And it looks like this. So these would be all of our parent function points, which you should already know. Okay. Similarly, the domain of this is all reals. It goes on forever, which is great. But the range is a little different. It's going to go from that bottom y value, which in this case is 0, to infinity. And again, these will change. The domain and the range will change a little bit with transformations. Okay, so the next one is a cubic function. So it has some similar points. It has the point 0, 0. It has the point 1, 1, right? Because 1 cubed is 1. And then it would have the point 2, 8, because 2 cubed is 8. Okay. And then on the other side, it would have the point negative 1, negative 1, because negative 1 cubed is negative 1. And negative 2, negative 8, because negative 2 cubed is negative 8. And so this looks a little different. So it would look, and this may not be my best drawing that I've ever done. Honestly, not the worst either. It looks kind of like a little squiggle there. Okay. And this has the domain of negative infinity to infinity. I know it doesn't really look like it in this picture, but it does keep going on and on forever. It's just kind of a skinny function. And then the range similarly would be all real numbers because it's going forever in both the positive and the negative y direction. So that's that one. Okay, moving on. The next one we have is the square root function. And so similar, we have the point 0, 0, right? Because the square root of 0 is 0. The square root of 1 is 1, so we have that point as well. Now this one we have to think, okay, well, what's our next perfect square? Well, 4 is a perfect square, and the square root of 4 is 2. So that would be this point. So this is the graph that looks kind of like this. Okay, like a little the domain of this, again, is restricted, right? Because we can't take the square root of a negative number. If we tried to plug in -1 here, we'd start getting into imaginary numbers, and that's a bit much. So that's why the domain is only positive. It's going to be 0 to infinity. And for a similar reason, the range is also going to be 0 to infinity. So then we can take the cube root, which looks a lot like the cubic function. It's just kind of curved on its side. So again, the cube root of 0 is 0. The cube root of 1 is 1, so that's fine. But similar to the square root, we're looking for perfect cube. So the next perfect cube is 8, and the cube root of 8 is 2. So it'd be 8, 2. So again, we kind of see those similarities between that and the cubic function. So again, this one does go in the other direction because we actually can take a cube root of a negative number. The cube root of -1 is -1. And the cube root, that doesn't look very good. And the cube root of -8 is -2. So again, this looks really similar to that one on the page before. It's just kind of turned on its side. They are what we call inverses. Again, we'll get to that at a later date. But similarly, its domain and range would be -infinity to infinity, which we maybe believe for the domain. But for the range, it does actually keep going up and down. We just don't really see it on this graph. Okay. The next one is what we call an absolute value function. Anybody know what this looks like? It should look like a V. And so it has the points 0, 0, 1, 1, 2, 2, and so on, 3, 3, 4, 4, etc. But this, so it has kind of a positive slope of 1 on the right side. So this side would look like this. But then what absolute value does is it makes everything positive. So we can, again, use symmetry. Oh, that is funky looking M to get the other side. So again, it is going to be -1, 1, -2, 2, and so on and so forth. And so it should end up looking like a V, which again, we hopefully know that it looks like a V. Because again, everything should be positive. That's why all of the Y values are positive. So domain didn't really change here, right? We can plug anything in. It's still going to be -infinity to infinity. But that absolute value makes all of those negative values that we plugged in positive. And so that's what makes the range 0 to infinity. And again, I'm including a bracket on those zeros because we are containing those points, right? We have points at that 0. Okay. And then the last one, and this is the trickiest one, is what we call the reciprocal function. So this one is going to have some restrictions. We see here that we have an x in the denominator, and that is what's going to make some issues occur. So the problem is that we cannot divide by 0. So that is going to be a restriction or an asymptote. So one of our asymptotes is going to be that x equals 0, right? Because if x equals 0, this function wouldn't work. So we would plot that. That's going to be a vertical line through 0. We'll do it as a dotted line so that we know that it is not something we can plot. And additionally, we're looking at this function, and y also cannot be 0, right? There's nothing that we could plug into this function to get 0 out. So that also gives us the pen's doing that. Come on. Sorry. There we go. So we also get the y asymptote of y equals 0. So there is 2 here. it looks like this. Now, if you're sitting here and you're like, oof, I don't know what the parent function points are, we can always kind of plug something in to see what we think might work. And so one thing that we could maybe plug in here, well, we know we can't plug in 0 because of those asymptotes, but let's try plugging in 1. So if I plug in 1, be 1 over 1, which is 1. So that gives me the parent function point of 1, 1. Okay, and we could plug in a couple of other things, but we could also see, okay, well, what's happening on the negative side? And so let's say I plug in -1 for x. So that's going to give me -1. So that means another point would be -1, -1. Okay, and so this function looks like this. So these are the two big parent function points that I'm going to be worried about you plotting for this one. For right now, we'll eventually get into some more points, but for right now, this is all we're worried about. And we don't want to cross those asymptotes. So we got to be really, really, really careful that we get super close to those, but we're not actually crossing them. We don't want to ever touch an asymptote. So we get super, super, super close, but we don't actually touch. And so it ends up creating a function that looks like this. Okay. And so the domain of this function would be from -infinity, again, left to right. So it starts at -infinity, but then this time it takes a break at 0. And we do want to put a parenthesis there because, again, we are not touching that asymptote at 0. And then we use what we call a union. So we use the U. And then it's going to be from that 0, again, parenthesis, because we are not including it. We're not touching it. And it does go on to infinity. It does keep going. The range of this would be from the bottom to the top. So again, it goes from -infinity. It takes that break at 0. And then we union. We pick back up at 0. And we go to infinity. So basically everything except for 0 for both of those. And that is, again, because of those asymptotes. This is probably the trickiest parent function. So just make sure you study it because it's also maybe the one that you forgot. Alrighty, but we are going to move on. So you will have a quiz, not next class, I believe, because you have to make up a quiz that you were supposed to have today. But you will have a quiz where it is literally like this sheet. It's going to be just these graphs. They'll be blank like I provided to you here, and you'll have to fill in the graph, the domain, the range, and any asymptotes if they have them. So just know that and make sure you're prepared for that. All right, now we're going to get into some transformations. So we're going to talk about first rigid transformations, which are transformations that kind of maintain the shape of the graph, meaning we're not making it skinnier, making it wider, nothing like that. We're just moving it around. We're not changing its shape, I guess. So the first one is a vertical translation. And so that's if we have our function and we add some number k to the outside of the function. So if that k value is greater than 0, that means if it is positive, we'll shift up however many units that is. Okay. Now, if we have a negative k value, a value where k is less than 0, we'll shift down k units. Again, this shouldn't be too new. You should have covered this a little bit in your Algebra 2 classes. So when it's on the outside, it's a shift up and down, and it's the same as what we think. Now, when we're working with horizontal translations, that's when it gets a little tricky. So if we have something where it's written as x minus a number h, that actually means that h is positive or, again, greater than 0. And so we're moving kind of the opposite of what we think. So we would think, oh, it's negative, I'm going to move to the left. But in actuality, we would be moving to the right h units. Okay. Similarly, if we had x plus h, that actually means because the equation is x minus h, this is a negative h. So h is negative, and we'll be moving the opposite of what we think. We'll move left h units. Okay. So the next thing we'll talk about is reflections, and there's kind of two types of reflections. One of them is when we reflect over the x-axis. So when the negative is out front, this is a reflection over the x-axis. That's probably the one we're going to see the most. Now, we may also see a scenario where we have kind of the x on the inside of the function, and this would be a reflection over the y-axis. We also have things called non-rigid transformations. Now, these are the things that are going to change your graph's shape. It's either going to stretch it or compress it, or a compression can also be called a shrink. So we just want to be careful with that. The bigger ones that we're going to work with are the vertical ones. So for a vertical stretch, again, that's happening where that coefficient is out front. When that a is bigger than 1, so like 2, 6, 3/2, anything like that, when it's bigger than 1, we call that a vertical stretch by that number, okay? And we will get into some practice with that. So when it is between 0 and 1, so not necessarily a fraction, it could be a decimal or something like that, but something that's like, 1/2, 1/3, 2/3, anything between 0 and 1, we call that a vertical compression. And so the way that we do those vertical stretches and compressions is we will multiply the y value of a coordinate by by whatever that coefficient is. Now, when we get into horizontal compressions and stretches, again, when it's inside, it's kind of the opposite of what we think, kind of like with those translations left and right. So when it's on the inside, when that a is bigger than 1, so 3/2, 2/3, whatever. I'm sorry, 3/2, 6, 7/2, whatever. That is actually a compression. So we would think, oh, it's bigger than 1, that's going to be a stretch. But the opposite is actually true. It's a compression. Similarly, if that number is between 0 and 1, like 2/3, 1/2, things like that, that would be considered a stretch. And that's because when we're talking horizontal, we are going to actually multiply the x coordinate, or the x value of the coordinate, by, instead of by a, it's going to be by 1 over a. And that's kind of what makes it the opposite. We're going to be working more so with vertical stretches and compressions, but we will do a few horizontal stretches and compressions. So we are going to start with graphing the transformations, stating them, stating the domain and the range. So when we do this, the first thing we're going to always have to identify is, what is the parent function? So if we're looking at this very first graph, we should hopefully be able to pick out that that parent function is going to be that cubic function. So it looks something like this. Now you don't have to, but I always like to plot my parent function, and I plot it with the graph and some dotted lines. So we have the point 0, 0, we have the point 1, 1. This parent function also has the point 2, 8, -1, -1, and -2, -8. Okay, and I plot it with a dotted line because I know I'm not done. So I only use solid lines for when I've finished all of my transformations. So this is what that parent function would look like. Okay, so now I have to figure out, what transformations am I working with? So here we have, we always want to do our transformations left to right. So the first thing we see here is a 2. Again, that is outside of the function, right? If it was inside, it would be like 2x to the third. So that's different. It's outside of the function. So that means it's going to be a vertical. It is bigger than 1. So it's going to be a vertical stretch by 2. And so that, what that means is, we'll take all the points we have right now and we're going to multiply just their y values by 2. So if I take 0, 0 and I multiply the y value by 2, it's still going to be 0, 0. That's not moving. Now, if I take 1, 1 and I multiply the y value by 2, again, the x value is not changing. That's going to turn into 1, 2. So it'll be here. Now, if I take 2, 8 and I multiply the y value by 2, that's going to be 2, 16. And if it doesn't fit on our graph, we're not going to worry about it. So then I do -1, -1, multiply that y value by 2 to get -1, -2. And -2, -8 would take me to -2, -16. Again, it doesn't fit, so I'm not going to stress about it. So this graph, we do want to go as far down as we can, but we don't want to create any new points. So we just got to be kind of careful when we're graphing this. But it should look a little stretched out for sure, because it is a vertical stretch. It should look like we grabbed it vertically and pulled it apart a little. So it looks something like this. Again, we have those points there. We have a 0 at 0. And our y-intercept here we should also see is 0, 0. Okay. Now, did its domain and range change? Not for this one. Again, domain is still going to be all reals because it's covering left to right. And even though we stretched it, it's still going to eventually cover everything left to right, even though it's like skinnier. And then our range is the same thing. It's going to be -infinity to infinity. We're covering all of those y values. Alrighty, next one. Okay, so we got a few transformations happening here. So again, we first want to identify what is that parent function. And it's a little hard to see, but the parent function is still x cubed. So it's still going to look like this. So we're still going to graph it with those parent function points. So the same ones we used last time, 0, 0, 1, 1, 2, 8, -1, -1, -2, 8, -8. That did not change. And again, I'm going to do it with a dotted line because I am not done yet. I got lots of transformations to go. Now, you can do each of your transformations in a different color if you'd really like to. But I kind of try to get used to doing them all together because we're going to be doing this kind of all year. So we got a couple of funky things happening. So we'll start with, again, we're going to work left to right. So we'll start with this piece, which is that 2. So that's still the same thing as last time. That is a vertical stretch by 2. So you can abbreviate using the word vert for vertical, but don't be abbreviating it to like VS, because the problem is there are such things as vertical shrinks. So I don't know whether you mean a vertical shrink or a vertical stretch when you write VS. So basically the abbreviations that I do are totally allowed, but don't push it too far. Don't just give me one letter. I need to know what you're talking about. Okay. So we got that vertical stretch. Now we have this little negative. So we should see that, okay, it's inside the parentheses. It's inside the function. So that means it's going to actually be a reflection over the y-axis in this scenario. But what makes reflections over the y-axis a little tricky is when they are inside the function, we kind of have to rewrite it a little bit. So if we have this function, this f of x, we still have the 2 out front. But I have to pull this negative out of both of these pieces. So I'm going to write that as, I'm going to pull the negative out, and then I'm going to be left with x instead of +1, it'll be -1. So in order to do those horizontal kind of transformations or the reflection over the y-axis, we have to pull out those pieces and kind of get it separated like here. So I just did that. So that means, okay, well now I can address this negative here. And so that negative, again, is on the inside of the function. And so that's going to be a reflection over the y-axis. And then we still have this transformation. Again, we want to work with the kind of corrected function. So this second one that we have here. And again, inside the parentheses, so it's the opposite of what we think. So we would maybe think, okay, well, I'm moving to the left. But again, inside, we're doing the opposite. We're actually going to be moving to the right one. Alrighty. Okay, so let's try it. We'll go 1 point at a time. So 0, 0. Can I vertically stretch 0, 0? No. Okay. If I reflect 0, 0, it ends up in the same place. So all I can really do with this one is move it to the right one. All right. Next thing we have is 1, 1. Okay, can I vertically stretch this? Yes, I can. It's going to be 1, 2, right? So it would end up here for the moment. But then I have to reflect it over the y-axis. So I have to reflect it, and it would go over here for a minute, right? Because that's reflecting over that vertical y-axis. But then I still have to move it to the right, so I'm still going to move it to the right one, and it's going to end up there. Now, again, if I tried to do 2, 8, if I vertically stretched it, it's going to take it to 2, 16. Reflecting is not really going to change that, and neither is moving it right, so I'm not going to worry about that. So we'll go -1, -1. Vertically stretching it is going to take it to -1, -2. Reflecting it is going to take it to 1, -2. And then it would have to move right 1 as well. And then the same thing that happened to 2, 8 is going to happen to -2, 8. So these are really the only 3 points I'm kind of worried about. Now I do, when I graph it, still want to kind of maintain the same shape a little bit. Again, I don't want to add any new points that I don't already have. So I'm making sure I don't cross any other axes here. And so it would look like that. So again, that's going to have a domain that is -infinity to infinity. And I want to make sure we can see it. Right, because again, the transformations for this cubic doesn't really change the function itself. So that one's good. And then the range would also be all reals. Again, we're covering all of those y values. Alrighty, next one. So this one we want to kind of, again, pick out that parent function. Hopefully we can see that it is a cubic. So it's this cubic, we see that here. So that's similar to the cube. I'm sorry, it's a cube root. Whoops. So that's similar to the cubic, but it's kind of on its side, if you remember. It looks something like this, okay? And so that had those parent function points of 0, 0, 1, 1, 8, 2, -1, -1, -8, -2. Okay, so that parent function kind of looked like this. Alrighty, so again, we want to do transformations. We're going to start left to right. So we start with this negative, and we treat this negative as its own thing. And so that negative is out front. We treat it as its own thing. That is going to be a reflection over the x-axis. And you do need to specify not just x, but x-axis for that one. So we have a reflection over the x-axis. And once we deal with that negative, we kind of forget about it. Okay, we've dealt with it. We said it's a reflection. We're going to move on to the next piece. And that is that 1/2. So again, this 1/2 is out front of the function. It's not under this cube root. So that 1/2 is going to be vertical. It's going to be a vertical, and 1/2 is between 0 and 1. So it's going to be a vertical compression by 1/2. Okay. So again, that 3 that's happening there, that cube root, is just telling us what the parent function is. So we don't really need to do anything else with that. So next we'll look at this piece. This is inside of the function. So it's going to be a shift left and right. And it's going to be the opposite of what we think. So you maybe think, oh, we're moving to the right. But actually it's the opposite. We are going to move left 1. And then finally on the outside, we have this -3. When it's on the outside, it's the same as what we think, and we're going to move down 1. I'm sorry, down 3. Alrighty, so let's do some transformations. So we'll start with a reflection over the x-axis. So again, 0, 0. Reflected over the x-axis is not really going to go anywhere. And then a vertical compression by 1/2 isn't really going to move it either. But we can move this point left 1 and down 3. Okay. So 1, 1 reflected over the x-axis would take us to 1, -1. It would take us down here. Vertically compressed, so we'd multiply again that y value, which is -1, by 1/2. So that's going to be -1/2. Okay, so that's like here, right? But then we still got to move it left and down. So it's going to go left 1 and down 1, 2, 3. So it's going to end up halfway between -3 and -4 there. We can also do 8, 2, reflected over the x, so that's 8, -2. Now, when I multiply that y value, that -2 by 1/2, that's going to take me to just -1. That'll take me here, which is kind of nice. We get a prettier point. But then that also still has to move left 1 and down 3. So that'll end up here. And then we'll do the same thing with the other points. So -1 will reflect over the x-axis to be -1, 1. We'll vertically compress it, so we'll multiply that y value of 1 by 1/2, so it'll be -1, 1/2. And then it will move left 1 and down 1, 2, 3. So it should be between kind of -2 and -3 in that y value. And last point, -8, -2, we will reflect it so that it's -8, +2. When we multiply that +2 by 1/2, that's going to take us down to just 1, right? And then, right, because 2 times 1/2 is going to be 1. Okay. You can always kind of check it to the side. And then we'll move that left 1 and down 3. So that would take us here. So our graph is going to look something like this. Okay, it should look a little squished, and that's okay because we did do a vertical compression. Alrighty, so again, that didn't really change the domain and the range. The domain is still going to be all reals for that one, and so is the range. Because we're still kind of getting all of those x and those y values. Alright, next one. Okay, so we are going here. So we're looking at some kind of new functions here, not so many cubics, but we see this little x squared. Oh, I'm going to start with a different color. We see x squared, and that is going to be our parent function. So our parent function is x squared. And if we remember, the parent function points for that one are 0, 0, 1, 1, 2, 4, -1, -1, -2, 4. Looks like this. Okay, so that's our parent function. And left to right, we really only have one transformation happening. We have this +1. So what does that +1 represent? It's going to represent going up 1, right? It's on the outside of the function. And so it's a shift up and down, and it's the same as what we think, so it's going to go up 1. So all that means is we'll just take every single point, and we will shift them up 1. This one's not too bad. And so this would be our graph, this green one. So then we do need to talk about the domain and range. So the domain is left to right. It is still going to be -infinity to infinity. But the range, which for our parent function started, if we go all the way back up here, started from 0 to infinity, because the entire graph moved up, that range is going to move up with the graph. So it's going to go bottom to top, 1 to infinity. So that range also has to shift up. Alrighty, next one. So this one, our parent function should be the square root function, which if we remember has 0.00, 1, 1, 4, 2. It's like a little half arc. Okay. Oh, didn't mean to do a solid line because I'm not done yet. Okay. And then we want to list our transformation. So again, left to right, first thing we see is this negative. This negative is outside of the function, so that means we are doing a reflection over the x-axis. Okay. And then we see this +2 on the inside. So what do we think that means? So it's on the inside, so that's a shift left and right, and it's the opposite of what we think. So we're actually going to go left 2. So we'll take this 0.00. It can't really reflect, so it's just going to go left 2. 1, 1 reflected would be 1, -1, and then it would go left 2. And 4, 2 reflected would be 4, -2, and it would go left 2 as well. So again, we don't want to kind of change the shape as much here. We're just going to still look like this. So it's going to still stop where that first point that we moved stopped and continue where it continued before. So we do have to change the domain and the range. So domain is left to right. So we shifted left 2. So that's going to be from -2. And then it does go on until infinity. Now the range was reflected. And so that means instead of going from a number to infinity, it's actually going to go from -infinity, and it stops at 0. So it's reflected. We can also, again, think about that as bottom to top. It's going down, and then it stops at 0. Alrighty, next one. So again, we have another parent function where we are doing x squared. We kind of see that here. So again, we're working with that, that quadratic, that parabola shape. So we'll plot 0, 0, 1, 1, 2, 4, negative 1, negative 1, 1, negative 2, 4. Is that parent function? Looks like that. So then we need to list out the transformations. So left to right, first thing we have is inside of this parentheses, we have a -1. So on the inside, it's left to right, opposite of what we think. So it's actually going right 1. And then we also have a -2 on the outside, which again, outside is up and down, and it's the same as what we think. So we're going down 2. So we'll just take all of these points and go right 1, down 2. Right 1, down 2. Right 1, down 2. Right 1, down 2, and right 1, and down 2. So this parent function looks, I'm sorry, not parent function, this final function, oh, that was a little shaky. Because we want to make sure it's curved, doesn't look like a V, looks something like this. Okay. So again, domain didn't change, it's going to be negative infinity to infinity, but that range did move around a little bit, right? We see that that range shifted down 2. But it's still going to infinity. So the range is going to be -2 to infinity. Alrighty. Okay. So next we have an absolute value one. So our parent function here is that absolute value. It looks like this, right? It's that V shape. So it is the point 0, 0, 1, 1, 2, 2, and so on. But also -1, 1, -2, 2. Remember, it is shaped like a V. Oh, gosh, dang it. Didn't mean to do these lines. Meant to do this. Whoopsies. Sorry about that. Okay. So next we got to look at those transformations. So we see this negative outside. Again, it's outside the function. That is a reflection over that x-axis. Okay. The absolute value bars are just telling us what that parent function is. And then we have this +2. It's on the outside, so that means we are going up 2. Okay. So we'll start with 0, 0. Can't really reflect that, so it'll stay there, and then it'll just shift up 2. 1, 1, reflected over the x-axis is 1, -1. And then it'll go up 2 as well. 2, 2, reflected over the x-axis will be 2, -2. And then it'll go up 2. -1, 1 will be -1, -1. And then it'll go up 2. And -2, 2 will be reflected to be -2, -2. And it'll also go up 2. So this will look something like this. As our final function. So again, we do have to be careful of the domain and range. Domain didn't change, it's still all reals, it's still left to right, it's still covering all of those x values, but range is bottom to top. So now range is -infinity, and it's stopping at that y value of 2. Alrighty. Okay, next one. Ooh, she's a doozy, right? You may not see it right away, but the parent function is that 1 over x. So it's the one that looks like this, right? That little funky one, the one that we did last. Okay, so if we remember, I'm not going to plot the asymptotes on this one just because we're going to have a lot of dotted lines going on. If we remember, the parent function points of this were 1, 1, and -1, -1. And it looked like this. And those are the only ones we're worried about moving right now. So the nice thing about this is we don't have to move a lot of stuff. Okay, so it looks like this. And then we got to look at our transformations. So technically that x -2, that means that -2 is inside of the function. So all that means is we're taking a shift left or right. And like before, it's the opposite of what we think. So it's actually going to be going right 2. Okay. And then that minus 1 is on the outside of our function, which means we're going to be going down 1. Now, if we remember, those asymptotes were originally at 0, 0. But those asymptotes are also going to shift right to, so this will be an asymptote, and down 1. So this will also be an asymptote for that final function. Okay, so now we can kind of look at those points. Again, that first one I'll move right 2 and down 1, so that'll be here. That other point I'll move right 2 and down 1, so that'll be here. Okay, and then we want to still kind of maintain a similar shape. So it'll look something like this. Okay. So again, we just said those asymptotes kind of moved. So they moved right and down. So that means our domain and our range are also going to move a little bit. So our domain is negative infinity to that vertical asymptote of 2. And then it picks back up at 2 and goes to infinity. And our range is bottom to top. It'll be negative infinity to that horizontal asymptote of negative 1. And then it'll pick back up at negative 1 and go to infinity. Alrighty. Okay. Last one. What do we think the parent function is? So don't let it fool you. This parent function is just a linear function, right? If we remember, it has kind of these parent function points, and all it is a line with a slope of 1, right? That is the parent function. It just has a few things happening to it. So we're still going to plot that parent function like we did for all the others. And you may say, well, I could do it with a slope of negative 1 and a y-intercept of 2, and you can, but we're really trying to, but we still have to list those transformations. We still have to do all of that. So we just want to be real careful. So that negative out front is a reflection over the x-axis. And then that plus 2 is our shift up 2. So we can do that with this function. So we will start with 0, 0. I can't really reflect that over the x-axis, so I'm going to just shift that one up 2. It'll end up here. 1, 1 reflected over the x-axis would be 1, negative 1. So it'd be down here. And then we'd shift that one up 2, which, funny enough, ends up where it started. And then we have negative 1 reflected over the x-axis is negative 1, 1, and then shifted up 2. So this would be a line that looks something like this. Ooh, my line is not great. You can use your ID if you need a straight edge. And this is still a line. So even though we transformed it, the domain and range didn't change from the domain and range of a line. It's still negative infinity to infinity. Alrighty, we're almost done. Okay. So this says list all the transformations. So we kind of got a lot going on here. So what we need to be careful of, though, is we kind of see some things happening on the inside. So that's what we need to be careful of. So the first thing we want to do is kind of rewrite this. So the negative out front is fine. The problem is going to be this 2. Again, when the 2's on the inside, we're going to kind of be worrying about horizontal stretches and compressions. But similar to when we had to factor out that negative, we are going to have to kind of take that 2 out. So when we take that 2 out, this is going to turn into x plus 2 rather than x plus 4. Okay. So now we can go ahead and start listing out those transformations. So our first one is that negative out front. Again, it is out front, so that is going to be a reflection over the x-axis still. Okay. The next thing we see is that 2, but that 2 is on the inside. So that means it's going to be a horizontal, and it's bigger than 1. Remember, it's when it's on the inside, it's the opposite of what we would think. So we'd maybe originally say, oh, I think that's a stretch. But it's actually not. It's going to be a horizontal compression. And that's because it's going to be by 1 over whatever that number is. So in this case, it's by 1 over 2, 1/2. And then we have that plus 2 on the inside, still kind of the opposite of what we think. So we're going to be moving left 2. And finally, on the outside, we have a -1. So we'll be moving down 1 because that's the same as what we think. And that would be all of our transformations for that one. Okay, real similar. The next one, we kind of have some funky stuff happening here. So we got to rewrite it, kind of pull things out. So we'll keep the 2 out front. That's totally fine. And so inside of these parentheses, we need to pull out a 1/3. So we'll take out a 1/3. And we'll take it out of that 1/3 x. But then we'll also take it out of that -1. So when we take it out of that -1, it actually turns that into -3. Now, you may not believe me, but think about it for a second. If I distribute this 1/3 out to -3, 1/3 times -3 is -1. So it would work if we kind of went the opposite direction. So that may take a little bit of thought to get used to, but that is what it would turn into. Okay, so we're still working left to right. On the outside, we have this 2. So that is still vertical because it's on the outside. It's still a stretch. And it's still by 2. Okay, where it gets a little tricky is this 1/3, right? It's on the inside, so that's going to be horizontal. And it's between 0 and 1. Again, it's on the inside. It's the opposite of what we think. So it's actually a horizontal stretch. And it's going to be a horizontal stretch by 1 over 1/3. So we got to look at that for a second. So 1 over 1/3. So we're thinking about fractions, we would multiply by the reciprocal, right? We would do 1 times 3 over 1, which is really just 1 times 3. So our horizontal stretch is going to be just by 3. Okay. And then we have inside of the parentheses, this -3, again, opposite of what we think. So we'll actually be moving right 3. And the +2 on the outside is the same as what we think. We'll be moving up 2. Alrighty. Thank you guys for listening. Make sure your homework's submitted and make sure you're working on your next homework. Have a good one.